on. AI is starting to think in new ways. We've got a brand new kind of model that can actually reason through problems step by step, like a human working through a puzzle. Then there's this wild system from Google that trains on completely broken smartwatch data, yep, missing chunks and all, and still figures out stuff like blood pressure and activity. Over at GitHub, they dropped a tool that lets you build full apps just by describing what you want. No code, no setup, just hit go. And if that's not enough, researchers built something called PyVision that lets AI write its own Python tools while solving visual tasks live on the spot. So yeah, AI is moving fast, so let's talk about it. Let's kick things off with something pretty deep but really powerful called energy-based transformers. Now, if you have ever used ChatGPT or seen image models like Midjourney or DALL-E in action, they're all built on this thing called the transformer architecture. Transformers are great at spotting patterns and finishing your sentences, literally. If you type "the capital of France is," it'll quickly spit out Paris. Easy. That kind of fast, automatic reaction is what researchers call System 1 thinking. But here's the catch. Those same models struggle when a task requires deeper thinking, what's called System 2 reasoning. That's when you need to stop, think things through, maybe test a few options, or verify that your answer really makes sense. Transformers don't naturally do that because they make decisions in one single pass. They take your input, zip it through a bunch of layers, and give you an answer all at once. Every question gets the same amount of effort, whether it's simple or super complex. That's efficient, but not flexible. That's where energy-based transformers, or EBTs, come in. These models still use the same transformer bones, but they bring in a new way of thinking. Instead of just giving you an answer, they score each possible answer with something called an energy value. Lower energy means a better fit. So instead of just guessing once, the model starts with a rough answer, checks the energy score, and then improves the answer step by step until it finds the lowest energy or best solution. You can think of it kind of like a human working through a puzzle and adjusting their guesses along the way. This method unlocks something really important: flexibility. If a question is easy, EBTs can solve it quickly in just a few steps. But if it's tricky, they can take their time and think longer. The model literally uses more compute power for harder tasks. That's a huge shift. Traditional transformers can't do that. They always work in fixed bursts. EBTs adjust on the fly. They also offer a clever way to check their own work. Since each guess has an energy score, the model knows how good or bad its answer is at every step. It can stop early when the score stops improving, or even generate multiple answers and pick the best one based on energy. That's something older models simply can't do. Now, training these models isn't simple. You need more advanced math behind the scenes, like second-order gradients and techniques that shape the energy landscape so the model can find good answers without getting stuck. But once trained, these models do something pretty amazing. They scale better. In language and vision tasks, EBTs have shown up to 35% better scaling efficiency than standard transformers. And they're not just good with text. They work across multiple types of data, images, video, even image denoising. One study showed EBTs cleaning up noisy images just as well as complex diffusion models, but using only 1% of the processing steps. So, while most people are focused on how fast AI can reply, EBTs are helping machines reason smarter, work longer when needed, and know how sure they are about their own answers. Now let's move from high-level reasoning to something more down-to-earth, literally. Your smartwatch, fitness tracker, or health band collects tons of personal data every day. Things like your heart rate, steps, temperature, or how well you sleep. But in the real world, that data is almost always incomplete. Your device might lose connection, shut down to save battery, or simply not be worn. And that creates huge gaps in the data, long, random holes that make it really hard to train good AI models. Until now, the solution was either to throw away those messy samples or try to fill in the blanks with guesses, also called imputation. Neither option is great. One wastes data, the other risks messing it up. But researchers at Google DeepMind came up with something smarter. They created a new model called LSM2, trained on a huge data set. 40 million hours of wearable data collected from over 60,000 people in just a couple of months. Instead of fixing the missing parts, their approach embraces the mess. They built a system called Adaptive and Inherited Masking, or AIM. Here's what AIM does. It first marks the parts of the data that are truly missing. That's the inherited mask. Then it also randomly hides some of the working data to train the model how to recover it. That's the adaptive part. This combo teaches the model to deal with both real gaps and artificial ones. The results are insane. The model improved its performance across all kinds of tasks. For example, it could predict hypertension more accurately, detect human activity better, and even estimate things like body mass index from partial data. When tested on signal recovery, the model reduced error by 77% on 2 signal gaps. It also held up way better when specific sensors were removed. And all this without ever imputing anything. Even better, LSM2 wasn't just trained to predict things, it can also generate data, recover missing chunks, and create strong embeddings that can be reused in other AI systems. That makes it super useful, not just for health monitoring, but for broader wearable AI in real-world environments where data is always messy. Okay, let's change gears now. What if you could build and launch a fully working app just by describing it in plain English? No coding, no setting up servers, no dealing with weird errors. GitHub's latest tool, Spark, is aiming to do just that. Spark is an AI-powered platform that turns your idea into a real app. Front, back-end, hosting, everything within minutes. You just type what you want, like, I want a website that lets users share recipes and rates them based on ingredient freshness, and Spark generates the full stack for you. It writes the code, sets up the database, integrates AI models, and even handles authentication and hosting. It's all built into GitHub. This thing runs on Claude Sonnet 4 and supports large language models from OpenAI, Meta, DeepSeek, xAI, and others. You don't need to mess with application, programming interface keys. It's all handled behind the scenes. And whether you're a beginner who just wants to drag and drop some user interface elements or a power user who prefers to edit the code directly, Spark adapts to your workflow. When you're ready, you just hit publish, and that's it. Your app goes live, hosted on Microsoft Azure, with all the security and scale you need. You can even assign tasks to Copilot agents to automate coding problems or launch a GitHub code space to go deeper into development. And now finally, let's wrap with a really cool research project for AI reasoning called PyVision. This one tackles a huge problem. Current AI models can recognize things in images, like objects, faces, scenes, but they often struggle when they have to actually reason about what they're seeing, like solving a visual puzzle, answering a complex question based on an image, or figuring out logic-based tasks tied to visual input. That's because most models are stuck with predefined tools. If the model doesn't already have a built-in function to solve a problem, it just gets stuck. There's no way to create new tools on the fly. PyVision changes that. Built by researchers from Shanghai AI Lab and several top universities, this framework allows AI models to actually write Python code during a task. When given a problem, the model analyzes it, writes some Python to solve it, runs that code, looks at the result, and then, if it's not happy, adjusts the code and tries again. It repeats this loop until it's satisfied with the result, and it keeps track of variables and progress between steps so it doesn't have to start over every time. It uses real Python libraries like OpenCV, NumPy, and Pillow to handle image segmentation, optical character recognition, enhancement, and other visual tasks. And the performance jumps are big. One test showed Claude Sonnet 4 improving by over 30 percentage points on a symbolic visual reasoning challenge. GPT 4.1 also gained nearly 8 points on visual search tasks. The key is flexibility. PyVision lets the model break out of fixed workflows and solve problems dynamically, just like a real person would. So yeah, all this stuff, energy-based transformers, wearable data modeling, app generation with Spark, and real-time reasoning with PyVision, it's not just research papers, it's the groundwork for where AI is headed. Smarter, more adaptive, more useful, and way more capable of handling the messy, unpredictable world we actually live in. All right, that's it for this one. If you enjoyed the breakdown, drop a like, hit that subscribe button, and I'll catch you in the next one.